I would rather work a job with a lower paycheck, such as teaching, and be happy because I like my students, I like the people that I work with and work for, and that's so much more fulfilling.
Dr. Vinciguerra, thank you very much for joining us. You are one of the more popular organic chemistry lecturers here at Texas State. Just to be honest, I took a different professor, but I've had plenty of friends who took your class. You got your PhD in organic chemistry at the University of Maryland. And throughout graduate school, I've seen that you've done a lot of teaching. So you clearly have a passion for teaching students and teaching and education in general. So the first thing I really wanted to kind of just ask off the bat is, what do you enjoy about teaching one of the most challenging classes for undergraduate students?
Um, well, I like teaching organic because it was hard for me as a student, and I had a really great professor, somebody who would not give up on me or allow me to give up on myself. And I like being able to do that for other students. I really think that anybody can pass Oakhim as long as you put in the effort and you know how to use your time and how to actually study. And so I really like, taking a student who maybe was struggling in Oakhim and just like giving them a couple hints and like a push in the right direction. And all of a sudden, like they're just nailing it. They love it. Um, that's why I do it.
So I don't know. When I took the class, and I know Edgar did as well, we definitely struggled through it as well. And some of the advice that I give out, because I've actually now since then been like an SI for organic chemistry, and I've become very familiar with the course and how challenging it can be for students. So some things that I personally did when I started on the classes, I would watch these videos, like lecture videos online that I would find as like a preview to the class, so that by the time the class started, I was at least familiarized with the content. What, as an organic chemistry lecturer, like what from your perspective, what are some of the things that perhaps a student who's probably going to be taking it next semester or next year, what is some advice you would say to a student like that, or maybe a student that's in your class right now, to be successful in this course?
Yeah. Well, first of all, what you said is already really good. Coming into the class, like even if you read just the overview of the chapter or you kind of skim it and it makes zero sense to you, that first exposure to the material makes it so much easier to absorb it when you're in lecture. Just because you're not sitting there going, I've never heard any of these words before, and you don't feel like you're being exposed to a brand new language for the first time. So even just like a rough pass through the material, even if you don't absorb any, is always really good before you go to lecture. Um, the other thing that I always tell my OChem 1 students is that like you take Gen Chem 1 and Gen Chem 2, and there's definitely relationships between the two of them, but you don't have to recall everything from Gen Chem 1 to be successful in Gen Chem 2. And a lot of the things that you need from Gen Chem 1, you can just kind of remind yourself of real fast, like, oh, I forgot how to name polyatomic anions. And so you go and look it up and now you have it and you're good. But in OChem, it's constantly building. So even though I'm teaching OChem 2 right now, I'm doing these multi-part reactions, and the first couple steps are pure OChem 1, and then you move into the OChem 2. And so you're always having to recall these reactions. And I think that's the biggest shock about OChem for most students is that it truly is cumulative. You are not allowed to forget anything.
Mm.
And the naming, especially, can be really stressful for a lot of students. So with the naming, that's definitely just practice. You have to practice all the time. Making some flashcards for the prefixes can really help. Um, and then there's the reactions. That's the part that really starts to trip up students, doing the reactions and mechanisms. I think the first thought for most students is to memorize, especially since OChem is often the first challenging class that students take in college. Usually, if you're taking OChem, you're a pretty smart kid. You're going to med school, you're going to dental school, maybe you're a chemistry major or a biology major. Whatever. You are there because you're smart, and it's probably your first like really big challenge. And so a lot of students come in there memorizing, which can get you pretty far until you see a reaction on a quiz or an exam. And even though it may only be different by 1 or 2 carbons and they're negligible, like they have nothing to do with the chemistry, students will completely freeze. Like I can take a problem that I worked with them in class and flip the structure over and add a carbon, and people will fail that question, even if they, memorize that exact reaction. So, what I tell my students is to approach everything broadly. Like instead of memorizing, acetic acid and ethanol and acid gives you ethyl acetate. Memorize that if you have a carboxylic acid and an alcohol and acid, that you're going to make an ester, and learn to recognize those functional groups and recognize the chemistry so that you're not trapping yourself to only know a handful of reactions when you could literally know all of them just by knowing the concepts.
Hearing all these words and all these reactions is giving me flashbacks
Yeah, it's a
from a
little
year ago.
causes a little anxiety. No, I
Yeah.
remember like what you said. The memorization doesn't get you all the way, and I have a whiteboard just by coincidence, but it's
Still
kind of
have
been
that?
erased since then. But at the end of the class, I had to write every single reaction that we learned. There's like, I think it's like more than 50, which sounds like a big number, but there's a lot of patterns and similarities. And the point is, I can't memorize that board. That was more just to put everything on one piece of, just a piece of whiteboard so that I could get a full view of just how much material there is in the course, but then at the same time know that it identify the patterns. And so I like that you brought up the idea that you can't just memorize it all. And that's something I didn't realize until the second course, organic chemistry 2, when I was, this is it's almost impossible. I mean, there's just too many reactions. You just have to finally start thinking about the chemistry and then just you apply that knowledge. And I don't know, since that course, I just feel like much more, for lack of a better way, just smart. Like I think more when I'm in my classes, and that's something you could look forward to as a student. Because I don't know, just since then and now in my biochemistry courses and advanced labs, even though I didn't take the organic labs in person, I have such a bigger perspective now of how chemistry works, and now when I go back to SI for like Gen Chem 2, I have just this like perhaps an overwhelming excitement when it comes to like talking about what is coming up for these students. And I just find that especially interesting is like how much you can change from one year. I mean, because I took it like a year ago, organic 1, and I think Edgar like a year and a semester ago. So it's like a catalyst in your undergraduate education. As soon as you take that course, you get over that hurdle, and now you're in your advanced classes, and it's a big jump, but it's definitely worth the ride, if you put in the effort, of course. Right?
I think you mentioned something when you were talking, Dr. Vinciguerra, that really resonated with me, and it was that organic chemistry is the first course that like really tests you as an undergrad. For me, it definitely was. I came in and general chemistry 1 was okay. General chemistry 2, I had to put a little bit more effort. And as a chemistry major, I was enjoying all these courses, and then organic chemistry 1 came, and it's like, oh, no calculator anymore, like put it away, we're not
Mm.
using it. And then I was like, we're doing chemistry with no it didn't make sense to me. And I remember sitting in those I had Dr. Allison, and I remember sitting in like the lectures like for the first 2 weeks, and immediately I realized, okay, like wow, this is gonna take some time and thinking. And after that, I think I went to Dr. Allison's office hours, and I was like, look, Dr. Allison, I'm a pretty hardworking person. I'm pretty determined, but I can tell that whatever I'm doing for other courses will not be the same for this course. Like how do I approach this? Like what do I do? And he recommended kind of like what you said, read the material beforehand, try to come into lecture with some type of knowledge, even if it's just you skim the chapter, it's still worth it. And even right now, in SI sessions, because we're both SIs, sometimes I like to briefly cover or just mention a few topics that we're about to cover. And I ask students if they're okay with it because I know it may be overwhelming. But the majority, the response is that they like to hear it before they actually hear it from the professor. So when they're hearing it from the professor, it's easier to digest. It's the second time they hear this. It's not, as quote unquote bad. But yeah, that definitely resonates with me. I remember taking organic chemistry and I was like, maybe I'm not as smart as I thought. And then it was just like, and I was like, maybe it's not that. Maybe I just have to rewire the way I learn
Yeah,
and
it's
not
definitely
just,
not
yeah.
bad.
Yeah.
And I want to emphasize a point is that like, you read ahead, you watch videos, expose yourself to the material. But something I didn't learn until maybe halfway through the first class is don't learn it by yourself. You don't have to like teach yourself the material. Just the idea is familiarize yourself with what you're going to be learning about, because then you might be spending way too much time on the course when you maybe don't need to, or maybe you could be focusing on the chapters you're currently on and learning those, and then at the same so that's because when you tell students like, oh, read ahead, look ahead, it's discouraging because it's like these are very dense chapters and it's a lot to read and it's a lot to learn. And so, well, you don't necessarily have to learn it all. You just have to sometimes see it all and prepare yourself and say, oh, okay, well, the next chapter is acids and bases. Interesting. What is that going to have to, like, how am I going to have to apply the first chapter nomenclature to that? So that is something I've one of the bigger takeaways from taking that class as well was like you can expose yourself, but you don't have to like learn it on your own either, which typically I think students find it's easier to do. Um, this is a great discussion. I wish I watched this when I was when I was in organic chemistry one. Um,
I wish I had done this when I was taking Oakhim one. I made it so much harder for myself than it had to be. Uh,
mm.
really, like just small amounts of effort frequently will get you so much farther than like a huge chunk of effort, right before an exam.
And it's harder, like on your mental health too. I mean, just doing a little every day it's much easier to just process the whole class and ultimately do well when you have to recall all that information on an exam.
Yeah. And also, Edgar, what you said, like that's one of the things that I like about teaching Oakhim is that students walk in there and they do kind of get shut down. Like you get to the stereochemistry chapter and maybe you can't like rotate things in 3D in your brain, but that doesn't mean that you're not smart. It just means like this is a brand new skill for you. And like that wasn't something that I was good at either when I was taking Oakhim 1 a million years ago. And I just remember, staring at this paper and like not being able to get it in 3D and then getting a modeling kit and putting my hands on it. And just with the practice, it literally does make you smarter because you are forging new neural pathways. And when you leave the class, you take those skills with you. Like you take the problem solving, you take that spatial awareness. Like I can now put furniture in any room. I can say, like, that's going to go through that door, is going to work. And my husband, who also has a degree in chemistry and math, his PhD is in chemical engineering. He doesn't do Oakhim anymore. And so, like, he'll fight me on it. I'm like, no, my spatial awareness is so good. And it's just because like I committed myself to that and I learned that. And now that's a skill that I have for life. And taking Oakhim really did make me smarter. Like once I really put in the effort and you just like push your brain through it, like even if it's not clicking, if you just keep like forcing yourself to work on it, one day it does click. That new neural pathway is there. And now that's yours for life.
Yeah, that's you mentioned one thing, that 3D like spatial awareness. That's like one thing that for a lot of people is not like intuitive. For some people, it like as soon as you mention it to them, like they get it. I remember that was one thing that I was like, "What do you mean it's coming out of the page?" I was like, "What do you mean it's going into the page?" Like I couldn't like visualize that until I think Dr. Allison like did like something with his hands, and then he was like this, like that, and then he's like he like made something that finally clicked in my head. And then after that I started just like I could visualize like the compound, and then doing those problems with like the stereoisomers, the um well, I'm going blank right now, but all those different types of isomers that you need to identify based on one compound. all those became so much easier, because then in my head I was able to rotate it, I was able to flip it, I was able to maybe just rotate a bond. But I remember that was not intuitive at all. That took me some time to fully be able to
Mhm.
like imagine a compound kind of.
Yeah, it's hard to take something like off paper that you draw flat with letters as atoms and then be like, oh, this is an actual thing that takes up space. Like, we draw a methyl group as a stick, and then you try to talk about stereo chemistry and steric effects, and I'm like, no, the methyl group isn't a stick. It's like a big dense chunk of electrons, because you have carbon and 3 hydrogens, and that's a lot of electron density, and it takes up space. Yeah, that takes time. It's hard.
But it's doable, and
It,
it can be fun if you put in the effort too. Um, well, let's change gears a little bit. So let's go back to what you said was a million years ago. You were an undergraduate at Texas Lutheran University here in Seguin, right?
yep.
So uh, one of the questions I want to ask is, you went to University of Maryland for your PhD. What was that transition like from, a relatively small private university to going to one of the bigger public universities?
Yeah, that's a really good question. It's kind of bizarre going into grad school, because grad school kind of is its own small thing. Like I knew the chemistry building, I knew where the gym was, I knew where the library was and the student center, but like I couldn't have told you like where English classes were on campus. Like you only really get to know like your department and the people in it and the space that you use. And so it still kind of felt like a small school. And then like I would go to a football game or something and be like, oh yeah, this is a big school. Like I think it was like 38,000 students. It was just a little bit bigger than Texas State. Um, and they had this huge stadium, and we would go to these games, and I was like, this is big. At Texas Lutheran, the football games were at Seguin High School. I think they have their own. I think they have their own stadium now, but like I was in band, and we just go sit in these like high school stands, and I was like, cool, this is going back a couple years in my life, but here I am, and watch Texas Lutheran lose all the time. Although, the second I leave a school, they start winning. Like TLU started winning the second I left. I leave Maryland and they beat UT. And I was actually at that game working concessions for a nonprofit that I work with. And I was so distracted because I was like, I'm at a UT game. Maryland is here and we're winning. What is
What's
happening?
going on?
Yeah. But yeah, to get back on topic, I'm so sorry.
No,
Yeah, it really is a challenge. Like I was so used to all of my faculty members knowing my name and having like personal relationships with them. And you definitely do still get that in grad school, but they also have their giant classes that they're teaching. And they're not in that mindset of like making a one-on-one relationship with students. And that's something else that I kind of struggle with at Texas State, is that I want that, because that's the type of schooling that I did. But like right now I have 200 Oakhim 2 students and 600 Gen Chem 2 students in labs. And there's no way I can have that with everybody. But I try.
You mentioned something that uh, took me back. Like I want to say maybe like 2 years now, 3 years now. When I was a senior in high school, trying to decide, where I was gonna go. Um, I applied to a lot of schools in Texas. I don't think I applied anywhere outside of Texas, but it basically came down to either UT or Texas State. And I ended up choosing Texas State, and if I'm honest, basically on the fact that they gave me the most money. Um, and I had never toured the school, I had never done any of that. But once I got to Texas State and kind of, got the culture, got the environment, I thought of transferring to UT after like my freshman year. And I don't know if you remember this, Nick, but I think I talked about it with you all. And it was basically like going to happen. It was like, after this year, I got the credits I need to transfer, and it'll just happen. But then I took a second and I thought about it. And what went through my head was, well, most of the department kind of knows me already, knows me at least by a face, maybe by name. I'm already doing research here. I could probably ask maybe more than three people for a recommendation letter. I have other things going on. like, do I want to go to UT that is like a bigger, more people? And it was basically that question of big fish in a small pond or small fish in a big pond. And looking back at it now, I'm happy and glad that I stayed at Texas State, because I don't think I would have had the connections and the relationships that I have with the faculty here as well as I would have at UT. I think, right? I mean, anything can happen, but I mean, so far, I think about that sometimes. Like, would I be able to just talk to the department chair like at a meeting, like whenever I kind of want to? Like, no, I don't think so. Or like, would I be able to send, one of my faculty an email about a recommendation letter? Would they even respond to me if I was at UT? Because that's kind of like what I hear from my friends that are at UT. Um, but it's definitely a different perspective. Like when you think of like a big school and then maybe like a relatively smaller school.
Yeah.
Or invite, a faculty member on your podcast, talk about some chemistry and their experience as an undergraduate. I mean, it's special. That's kind of my attraction to the Texas State department too, and it was a small knit group, very friendly faculty, and it feels good. It feels good to be a student here. Um, Changing gears again a little bit. I heard some friends say that you were perhaps considering a career as a physician when you were an undergraduate too, or you medical school maybe, and maybe some other careers were on your mind at the time. I mean, like most students. I mean, me and Edgar too. And you know, what what was like the final what allowed you to make the final decision? Okay, I want to study organic chemistry, or what experiences did you get, and how did you finally come to that decision?
Yeah, so I started off at TLU as a music major, and I was also pre-med. And so I was taking a lot of music classes, obviously, and I was taking all of my basics for my pre-med major. So I was taking a biology and general chemistry. And I found that I was really good at chemistry. And one of the faculty members immediately started harassing me, like, you should be a chemistry major. Why are you a music major? Music's great, but you need to be a chemistry major. You're good at this. Like, this is natural for you. And he would just say it every day. And that's not really what changed my mind, but I started just enjoying those classes more, just because like it was something that I was good at until Oakhim happened. And then I, struggled for a little bit and then found my way. Um, but like that's kind of what got me to switch. And also like studying music for some reason that kind of killed the fun of it for me. I don't know why. I loved music theory. It's like the Oakhim of the music world. I still
That's
don't know
really
if it's
nice. Wow.
harder. Yeah. I don't know if music theory or Oakhim is harder, but music theory was 4 semesters of so much hard work. um, but what ultimately caused me to drop the pre-med thing was just that I kind of decided that I couldn't handle having a life on the line. I wanted to be a surgeon. That was kind of the area that I just wanted to move into. Any job that I've ever worked, like I have to be able to work with people and see an impact in their lives. Like that's the only way that I can do a job, is if I know that I'm making a difference, that I'm helping somebody. And so that's what pushed me towards the medical field. And then honestly, I think I kind of chickened out. And sometimes I'm not sure if I made the right call, but I do love to teach. That was the other thing I noticed, is that, my jobs in college, like I worked at summer camps, and then I was a peer mentor, and I was volunteering to teach like little portions of classes and stuff. And I was like, this is something that I could do and be happy about and still get that feeling that I'm making a difference for somebody. And by the time I finished Oakhim, I was like, that was hard and I figured it out. And I want to do that for somebody else. Like, I want to make that possible. And also, I want to know it better. Like, I just wanted to keep working on it. And I wanted to be able to say, like, one day that I was truly the master of Oakhim, I guess, like that I finally, beat it and understood it and, could explain it and teach it. It was like a personal challenge, I guess.
You say you don't know if you made the right decision. I think you did, because maybe Nick can back me up on this, but I definitely appreciate a professor who actually likes teaching than maybe a professor who's just there to be there. And it's very apparent, you can definitely tell when a professor likes what they do, like likes the field, likes teaching, has passion behind, cares, puts in a little bit of extra effort, to the one where it's just, I'm gonna be here because we all have to be here type of thing.
Yeah.
And sometimes it is just a case of where your priorities are, which is understandable as well. But it's nice to see your one of your biggest priorities is in teaching the students. And I think you were talking about a second ago the challenge that you wanted to like overcome, and you know, in organic chemistry, and you wanted to learn more, and then looking back on it, I don't think I mentioned it to Edgar, but I was digging through my closet the other day, and I found my Gen Chem 1 binder with all these like quizzes, and I was having a pretty stressed out evening, just a little homework on some of my current classes, and it was like it wasn't overwhelming, but it was like, oh, I've actually learned a lot since then. I've actually come such a long way, so that was a very therapeutic, just a single moment of my evening that I found very interesting. It was because I don't know. Sometimes you just go so fast, and then you look back, and you're like, you should kind of pat yourself on the back every once in a while and say, well, what I'm doing now is really hard, and it can be a very big challenge. But like, look, I thought the same thing about polyatomic ions, like what you said. That was also really nice to appreciate. Um, back on on your deciding your career, did you have any experiences like did you do research as an undergraduate? Did you, you did, you want to talk a little bit about your research experience as an undergraduate?
Yeah, I kind of did a bunch of different little projects in undergrad. One of them was working on like different formulations of polyurethanes, just to try and get different properties. Um, that one was fun. That was my like summer work, and I believe that's something that that professor is still interested in. He's moved to a different university, somewhere up north since then. Um, and I also got my NMR experience working in that lab. So that was fun as like a new skill. And then I remember my senior year, I was doing an individual research project, and it's weird, like college is kind of a fog now, and I can't remember why, but I started doing transition metal catalysts, to catalyze organic reactions and stuff. So my undergraduate experience was really weird because I never like, there weren't research labs at TLU. Like there isn't like, this is so and so's research lab and he does this work and they're constantly publishing. It's not really like that. It's more like, this is something that this professor is interested in, and they're looking for students to come and help. And maybe it'll be a publication, maybe it'll just be a fun project. Um, so that was like the bulk of my research experience. So getting thrown into grad school was an awakening, to actually, like really, really dig into research. But my undergraduate research experience mostly showed me that I could do it, that I could read papers and draw my own conclusions and create my own hypotheses and try them and see what happened and fail and try again. I think that's probably the most valuable thing that you can get as an undergrad, if you're only going to do research for a really small amount. Like I really like that at Texas State, a lot of you guys are able to get into labs and stay there for years, and actually, get publications, get through a project, really contribute to something. My experience is more just like learning what research feels like, I think.
Hmm. And that is really what it is, in the beginning, at least. I mean, I know. So I've been doing research for 6 months now, in Dr. Peterson's biochemistry lab, and that really is just understanding what it means to do research and learning the fundamental skills like pipetting. Or so, I mean, and then now I finally do have my project that I'm working on, and so that is I like how you made that point, is like, part of it is just learning how to do research, because I mean, at Texas State at least, I mean, we only really start getting previews into that in our upper level classes. So like you know, advanced biochemistry lab or you know, advanced chemistry lab. That's when we really start to get our foot in the door. But doing that as an extracurricular can also be very valuable. We're talking a lot about research, so it's only appropriate to mention the REU program at Texas State. So you are like, I guess, in transitioning to becoming the new program director for this. It's called the Chemi RU. It's CHE, capital M, capital I, capital E,
Yeah.
Chemi RU. I'll give my best brief explanation of this for anybody who might not be aware, but it's a nationally funded program for several universities across the nation, funded by the NSF. And it's basically a immersive summer research experience for undergraduate students where they can travel to other universities. They get paid a $5,000 stipend. It might vary between each university, but for this program, it's $5,000. And like I said, immersive research experience to really get your foot in the door, and see if whether or not this is a career you'd like to pursue professionally. So Texas State has one. I guess due to COVID, they're only accepting students from Texas State, which is special. You know, this is a podcast for Texas State chemistry students, so that is something that, you know, students could take advantage of as well. But, you know, why do you think students might want to consider joining an RU? We've already kind of talked about, like, it's a great way to learn about research and learn some new skills. What are some motivations you have students consider? Like maybe a student in your class approached you and says, you know, I'm thinking about maybe doing something this summer. What would you kind of tell them as encouragement?
So an RU, like you said, is a good time to just get that experience, and it's not really a big time commitment. This summer it could be, if you're doing the Kinney RAU here at Texas State. You know, if you join a lab for those 10 weeks in the summer, that could turn into something long term for you.
Yeah.
Is one reason that, you know, Texas State students should apply. National RAUs are really competitive. And this summer, so many RAUs just either aren't happening or they're happening only locally. And that just means that there are more spots here than there ever have been. We're taking 14 students. Usually it's closer to 10. So there are more spots, and it's only for Texas State students. And then you have the unique opportunity to actually stick with that project after your RAU, which is not what would normally happen. Because you would, you know, you'd go to another school and then you'd go back home and
Go
you
back home.
never see those people again. And like you might kind of, you know, get your foot in the door. Maybe your name ends up on a publication later if you got some good work done. But yeah, so this one, I think for Texas State students, it's a good opportunity because the competition is lower. I'm not saying that students can't get into national things. It's just the number of students applying to national RAUs in a regular summer is obscene. Just a lot of students, and it is competitive because there are only so many spots. Usually an RAU comes with housing and food, but since we are currently in the middle of a pandemic, we can't offer housing. And that's actually why we have more spots, is because that money was saved. And so now that money can be used to pay more students. So yeah, there's that opportunity in itself. The Texas State Chemi RAU is really unique because it focuses on molecular innovation and entrepreneurship. So if you look at RAUs around the nation, you'll usually see that each of them kind of has their own theme, essentially. Like you could find some that are about green chemistry. You might find some that are actually very focused on just one field. You can find them that are focused on polymers and materials. Here, you can pretty much research anything, but you're also going to attend a boot camp at the very beginning of the RAU. It won't be spaced out through the program, where you learn about entrepreneurship in scientific fields. And then throughout the program, there's also professional development, which is so important as an undergrad. as somebody who recently, read through applications for people applying to the REU, I've read through scholarship applications. I've written letters for students. And so um, I see CVs from students all the time. And getting the opportunity to have somebody help you with your CV is so important. Um, and that's one of the things that you can get, in any REU really, is going to have some professional development. You'll learn about scientific communication, applying to grad school, and applying to jobs. Those are also two big professional development focuses. Learning about being a scientist in the industry, not necessarily in academia. That's something that you don't often get to see because you are at school. And so the research experience you have is academic. But we have a lot of faculty members who have industrial experience. Dr. Whitney Weber, who is also going to be doing the RU with me, we're doing it together. We'll be co-program directors. Because honestly, it's too much work for one person. So I kind of feel bad for Dr. Holland that he's been doing it by himself for a long time. But she actually was at Dow for a long time. And so she has a lot of industrial experience. My only other research experience was at a government lab working at NIST. So these research experiences over the summer gives you time to talk to faculty members and learn about their histories, because most faculty members, they have experience outside of academia, and you just have to ask and find out what you're interested in. There are so many opportunities for somebody with a chemistry degree, and those opportunities are very broad. And you'll also learn about ethics in research. Obviously, ethics in research is really important.
It's important.
It's really important not to lie in a publication or to fabricate your results. And ethics goes further than that as well. But those are the types of topics that you would cover in a professional development series. I'm trying to think what else.
Well, if I might, I remember when Dr. Lewis was kind of advertising the program to our course. She said, this training or education about the business side of chemistry or STEM is really important, and it's not necessarily something you'll get in like grad school or something. I mean, this is something that you'll either learn through industry experience, or maybe you have a business background in a major or a minor in business, but it's not a very traditional a core component of our education. So being able to take 10 weeks of your summer and really get to know about that, and like you said, learn about some of the stories that faculty here have with their industry experience. Shout out Dr. Weber. She was one of our previous guests on the podcast. She talked about her work at Dow for, at length. So that is really fruitful as well. I don't know. I love startups. So being able to get a little bit more of, know more of how to carry out a startup could be very valuable if you want to start a business when you're doing your research. Maybe you come up with a cool product. I think that's fascinating, and it's unique to the Texas State REU program. I don't believe all programs across the nation do this. They might have more concentrations than other things, but that's something unique to Texas State, which is also something you might want to consider when you're applying. I think the priority deadline is the end of March 30th, but also you can apply up to the end of April, I believe. So still some time to draft up an application. It's not very long. I've done it myself. And I think you do need 2 recommendation letters, though, from some faculty members, or I think maybe your research, your PI or something. But it's not the most, thorough application, but it's worthy to get started on it. Maybe over spring break if you can, with the extra time you have. So we talked about some unique opportunities that this REU has to have. I don't know. I think we covered it pretty well. I guess to finish it off, in honor of the WISE conference that would be happening now or in March. Unfortunately, due to COVID, it was kind of canceled, or repurposed to do like guest speakers throughout the semester. But you know, in honor of that, I kind of want to ask just a sillier question, but is there a woman in STEM that you know inspires you or has significantly inspired you, or you really admire that you maybe want to give a shout out or acknowledge?
That is both a really broad and really specific question somehow. Um, most of this, I don't know if this is exactly the type of answer you're looking for, but one of the things that I really like about working at Texas State is that the department does have women, and there are women who've been teaching here for a long time. And coming into Texas State as a new teacher, like I had taught before, but I'd never been, instructor of record, and um, it's a huge responsibility. And I was lucky to have Dr. Deborah Feeks to look up to, and Dr. MJ Patterson. Both of those women are so compassionate and so strong and smart, and they've both been uh, really big role models for me. I'm lucky that I've gotten to work with Dr. Patterson a lot the time I've been here. She was in charge of the Gen Chem 2 lab when I got here. And then I started working on that with her, and we've been writing a lab manual. And then she left the Gen Chem 2 lab, and I was just doing it by myself until we hired Dr. Weber, and I finally didn't have to do it by myself anymore. Um, but I'm really lucky to have those role models directly in my life. It's not easy to be a woman in science. It's not easy to be a woman in industry or academia. It was great to come in as, a very young teacher. I think I was 27, 28 when I started teaching at Texas State. And so I was young and I was female and scared that nobody would take me seriously. And then I would watch Dr. Patterson or Dr. Feeks teach. I saw their classes, or I saw them, interacting with their students, and they were respected by their students, and not because they were, like hard on them, like they didn't demand respect. They demanded respect by respecting their students and by being good at what they do. And so that was something that I tried to emulate immediately. I was like, how do I be those people? How do I be that confident and, compassionate and caring for my students without having them walk all over me? Because sometimes you students can do that, or you can try. It doesn't work as well with me anymore. But yeah, they've been my more recent role models in STEM, I guess.
That's nice. I'm currently an SI for Dr. Patterson, so yeah, I'm sure she really would appreciate hearing that too. And I completely second everything you just said about her. She's extremely compassionate, personable person, and just overall a good person to have on the in the department. Um, so I guess you kind of hinted at some of the challenges about you might have faced as a woman in STEM. Looking at where you are now, Dr. Vinciguerra, what would you have told yourself? Is another silly question, but what would you have told yourself at the beginning of your STEM career?
Um, so many things, to be honest. Probably one that I've been thinking about a lot recently, and I don't know why this has started weighing on me so much. Um, but it occurred to me that there were times in grad school or even in college where sometimes being a smart woman, people don't like that. They don't want to hear that you're right and they're wrong, even if you are right and they're wrong. And so I would often just not put myself out there. If I had a good idea, or if I, had something to contribute in any way, I would often keep it to myself, because I thought that I would get farther that way. Like I thought if people weren't threatened by me, which is crazy to me. Like I'm 5'1". I don't understand how it can be threatening, but I kept to myself, and I thought that that was the right way to do it, because that was what I had seen other women in my life doing. But now, working with Dr. Patterson, Dr. Feeks, all the women in our department are pretty amazing, actually. You don't have to do that to be successful. I don't worry so much about whether people like me anymore. And I find that actually makes me more likable, I think, because I can just be myself. And I'm not saying that I'm like a genius or something, but apparently some of my students think that, which is like, that's wild. Um, but like that's something that women go through though, is like we're often told like, if a man is strong, people call him strong and they say like he's confident and he's good at what he does. If a woman is strong, we are many words that I will not use on your podcast.
Disrespectful. Yeah.
Yeah. And I've seen those in some of my teaching evaluations and stuff. And that makes it really hard to just like be yourself and be your best self as a woman in science, because a lot of people don't want to see you be successful. But you can be. You just ignore that and put yourself out there and be you and be as smart as you are. And that's better. It's hard, but it's better.
You mentioned something that I think, even if you're not, like maybe this doesn't particularly apply to you, like the topic that we're talking about, but just in general, I think when you stop when you stop caring about what other people think of you, you excel so much in life, in everything in general. Like when you stop having that second thought of, well, what are they gonna think, or, well, what are they gonna say? What are they gonna, rumor about, or what are they gonna think about me? I think that took a while for me as well. Just like being confident in like myself and my answers and my work. Of like, oh, well, what are they gonna say about it? What are they gonna, do about it? I think once you get over that hurdle of, it doesn't matter what they think. I'm gonna do me. If it works, it works because I did it, and progress. And that's a very like hard hurdle to get over. But I think once you do, it really makes you go way farther than you could have before.
Yeah. And one of the things that's great about this department is, not just the women that I have to look up to, but the majority of the male faculty that I've interacted with, they value me, because I'm a woman, and in spite of it, however you want to phrase it. But they know that I have something different to bring to the table, that I'm going to look at problems differently. I'm never afraid to go to Dr. Britton and say, like, this is something I've been thinking about and I think it's important and I want to do it. And he'll say yes, like almost immediately, because he wants me to feel like I can do what I need to do to be successful here. And he values my input to the department. And, that's a really good situation to be in. And that's getting that type of positive reinforcement really showed me, like, how important it is to like the people you work with and the people you work for. I think that's another thing that I would tell like any young person in general, like science or not, but especially in science, because science can be any STEM field, doing research, things like that. It can be hard. You can, work for some rough personalities. Liking who you work for and being able to trust them and know that they support you and respect you as a student, as a smart human being, it's more important than how much you get paid. I would rather work a job with a lower paycheck, such as teaching, and be happy because I like my students, I like the people that I work with and work for, and that's so much more fulfilling. I would never. I've worked for some people who were not great to work for. They were very challenging. They didn't respect me, didn't value me, made that very clear many, many times. It was not worth it. Not even a little bit.
Well, you mentioned your role models here at Texas State, and I just have to say that Texas State has a huge female population of students. And I definitely think many of them would consider you one of their role models in the department among those that you just mentioned. So it was great, getting to sit down, meeting you for the first time. And thank you very much for being on the podcast and getting to share some of your wisdom and advice. Just thank you very much. And this was awesome, I gotta say.
Yeah, this was great.
All right, well, yeah. Bye, everybody.
Bye.